10 amazing arrangements of the universe. The universe seems to have been designed just right in a way we can't fathom. Stephen Hawking. Ever wondered how incredibly precise this universe you live in is? From the rotation of the Earth to the burning of stars, every subtle detail is like a carefully choreographed performance. It's as if an unseen hand has adjusted everything to just the right spot. This is no mere coincidence, but a series of breathtaking arrangements. Today, we're going to unveil 10 of the universe's most amazing perfections. Hello, and welcome to my channel. 1. The history of meteorite impacts. Why just-in-time brings both crisis and opportunity. Have you ever thought that meteorite impacts are just the right thing for the Earth? It may sound a little outlandish, but who thinks a rock falling from the sky is a good thing, right? But if you think about it, all the big events in history, both catastrophic and somewhat fortunate, have had something to do with these celestial visitors. Let's start with a familiar story, the extinction of the dinosaurs. It happened about 66 million years ago, when an asteroid or comet roughly 10 kilometers in diameter slammed into what is today Mexico's Yucatan Peninsula, leaving behind the famous Chicxulub crater. By analyzing the geological structure of the area, scientists found that the impact was equivalent to the simultaneous explosion of billions of nuclear bombs. At the moment of impact, the enormous energy released triggered a global catastrophe. The ground shook violently, volcanoes erupted, and tsunamis reached hundreds of meters high. These are just the immediate consequences. What's more frightening are the long-term effects. The immense heat from the impact ignited the surrounding forests, leading to global fires. Huge amounts of soot and aerosols were thrown into the atmosphere, creating a barrier that blocked out the sunlight, causing the climate to cool rapidly in what is known as impact winter. Plants wither because they are unable to photosynthesize, destroying the basis of the food chain and causing ecosystems to collapse. In more detail, the marine ecosystem was also hit hard. Sulfate gases released by the impact caused acid rain to fall, altering the chemistry of the oceans and making many marine organisms extinct. Meanwhile, the dramatic drop in temperature made the tropics colder, the colder regions harsher, and the global shrinkage of habitats left a huge number of creatures with nowhere to go. Sounds pretty tragic, right? But on the flip side, this extinction event also freed up ecological space for mammals, especially our ancestors. Mammals survived the catastrophe due to their smaller size and greater ability to adapt to environmental changes. Scientists have even joked that without the meteorite, it would have been the dinosaurs who would be ruling the planet instead of us. Some studies suggest that the dust and aerosols from the impact blocked out sunlight, causing a dramatic drop in global temperatures, similar to the effects of a nuclear winter. However, this catastrophic environmental change also prompted the surviving species to adapt quickly, ultimately shaping today's biodiversity. Not only was the meteorite responsible for the extinction of the dinosaurs, but the origin of life on the early Earth may also have been aided by meteorites. Do you know what life needs? Water, carbon, and some key elements such as phosphorus. Phosphorus is an important component of DNA, RNA, and ATP, the energy currency of life. Interestingly, phosphorus may not have been enough for the early Earth. Research shows that phosphorus-rich minerals may have been brought to Earth via meteorites. In particular, those iron-nickel meteorites contain something called schreibersite. This mineral is very rare on Earth, but common in meteorites. Scientists even discovered a phosphorus-rich meteorite in 2013, which directly supports the hypothesis that meteorites bring the elements necessary for life to Earth. Did you know about mild meteorite events? The Earth has experienced 5 mass extinctions in its history, each associated with dramatic environmental changes, and several of these changes were associated with meteorite impacts or volcanic eruptions. Surprisingly, although extinction sounds very negative, the Earth's ecosystems always recovered more diverse after each mass extinction. For example, it was after the Permian-Triassic extinction, about 250 million years ago, that the ancestors of modern reptiles, mammals, and dinosaurs had a chance to rise. Without that catastrophe, it's possible that certain early species would have remained dominant and others would never have had a chance to emerge. In addition to the elements, meteorites may have brought water to Earth. About 4 billion years ago, during the late heavy bombardment, the Earth was bombarded by a large number of comets and asteroids. Many scientists believe that the water ice contained in these objects may have seeded the Earth with a lot of water. One cool study came from the European Space Agency's Rosetta mission, which found that the water from Comet 67P/Churyumov-Gerasimenko contains a different deuterium/hydrogen ratio than Earth's oceans. However, other studies have pointed out that the water in some carbonaceous globular meteorites is very similar to Earth's water. This suggests that there may be multiple sources contributing to Earth's water resources, with meteorites playing a major role. Of course, the moderation of meteorite impacts is a matter of luck. Larger impacts could destroy the planet outright, while smaller impacts would not do much good. To prevent future inappropriate impacts, scientists have been studying how to deflect or destroy potentially threatening asteroids. For example, NASA's DART mission, Double Asteroid Redirection Test, successfully impacted one of the moons of the asteroid Gemini system in 2022, changing its orbit. This proves that humans can push away threats when necessary. On the other hand, scientists are also excited by the resources that meteorites bring. In the future, we may start asteroid mining to obtain rare metals and even water for space exploration. From the early origins of life on Earth to the rise of the modern human race, meteorite impacts seem to have been the driving force. They have pushed the reorganization of ecosystems at just the right time, without completely destroying the entire planet. This just-in-time simply makes people marvel at nature's art of coincidence.
2.
2. The rate of heat depletion in the Earth's interior. Why is it just right to support geological activity to this day? Did you know that the Earth is the way it is today, thanks to the just right pace of its internal heat? Yes, this sounds like some kind of miraculous luck, but scientists have actually done a lot of research and found that this just right rate of heat release is the key to Earth's long-term stability. Where does Earth's heat come from? First of all, heat inside the Earth comes from two main sources. One is the residual heat from the early stages of the Earth's formation. About 4.6 billion years ago, the Earth was just a hot, constantly colliding collection of stars. The energy released by all these collisions turned the Earth into a lava planet. This primordial heat has survived to this day. Another part of the heat comes from radioactive decay. Certain elements inside the Earth, such as uranium, thorium, and potassium, decay slowly over time, releasing heat. The half-life of these elements is very long. For example, the half-life of uranium-238 is 4.5 billion years, basically the same age as the Earth. Therefore, the Earth's internal heat generator is still working today. Why is the release of heat important? You may ask, what does it matter if the heat is slowly dissipated? It matters a lot. The heat inside the Earth drives geological activities such as plate movements, volcanic eruptions, and earthquakes. These activities not only shape the Earth's landscape, but also have a profound impact on the origin and evolution of life. If the heat in the Earth's interior had dissipated too quickly, geological activity might have stopped billions of years ago. Without plate movement, there would have been no new landmasses to create and no volcanic eruptions to release gases to keep the atmosphere circulating. And if the heat dissipated too slowly, the Earth could turn into a blazing inferno like Venus, with volcanic activity too intense to be suitable for life at all. The Earth's plate motion is arguably the key to keeping it alive. This motion is driven by mantle convection, which in turn depends on the release of internal heat. As an example, imagine a pot of water. If you heat it at the bottom of the pot, the water convects, hot water rises and cold water falls. The principle of flow in the mantle is actually similar, except that the pot of water is much hotter, reaching thousands of degrees Celsius. It is this convection that splits the crust into plates and pushes them to keep moving. Interestingly, this movement is very slow, at about the rate of a fingernail growing. But it's this slow movement that brings about mountain building, seafloor spreading, and seismic activity. Without this, the Earth's surface would be a flat, dead place. Volcanoes are probably one of the Earth's most spectacular geologic events. Imagining lava spewing forth is both spectacular and a bit terrifying. Volcanic eruptions release heat that is built up inside the Earth while releasing carbon dioxide, water vapor, and other gases into the atmosphere. These gases were crucial to the regulation of Earth's early climate. Scientists believe that the early Earth's atmosphere was formed primarily by volcanic eruptions. Without the greenhouse gases from volcanic activity, Earth might have become a frozen planet long ago. Of course, volcanoes have a destructive side, such as the 1991 eruption of Mount Pinatubo in the Philippines. It blasted so much sulfur dioxide into the atmosphere that it caused global temperatures to drop by about 0.5 degrees Celsius over the next 2 years. But in the long run, this kind of activity actually helps the planet maintain a dynamic equilibrium. Why is Earth so special? At this point, you may wonder why the rate of heat release inside the Earth is so just right. It has a lot to do with the size of the Earth. The mass of the Earth is large enough to retain the heat inside, but not so large that it produces too much heat, as Jupiter does. Looking at our neighbors, Mars and Venus are not so lucky. Mars is so small that it ran out of internal heat a long time ago and is now almost geologically inactive. Venus is about the same size as Earth, but it may have become overheated due to lack of plate movement. Earth, on the other hand, has found a delicate balance of having enough heat to sustain geologic activity without being too violent. To better understand the rate at which heat is consumed within the Earth, scientists have used a variety of methods. For example, they have used seismic waves to study the structure of the Earth's interior. Whenever an earthquake occurs, seismic waves travel through the Earth's interior, and different materials cause the speed of these waves to change. By analyzing these changes, scientists can speculate about the temperature distribution inside the Earth. Another method is to analyze the amount of radioactive elements in volcanic rocks. Because these elements decay over time and release heat, scientists can deduce the source of heat inside the Earth by measuring their proportions. Will we run out of heat in the future? Of course, the heat inside the Earth is not infinite. Scientists estimate that the amount of heat inside the Earth decreases by 10% about every 100 million years. That means that after billions of years, the Earth's geologic activity may come to a gradual halt. But that's a very distant future for us. For the next few 100 million years, Earth will remain a vibrant planet. And we will continue to benefit from this just right rate of heat release. 3. Human lifespan. Why is it just right for society? Have you ever wondered why the human lifespan is what it is now? An average of 70 to 80 years old, with an upper limit of almost 100 years, sounds neither too short nor too long, but it seems to be just right. Not only can we learn some wisdom in life, but also not so long as to make resources consume a disaster. Is there a sense of cosmic arrangement behind this? Let's start from the biological point of view. Scientists have found that life expectancy is related to many factors, such as genes, the accumulation of cellular damage, and energy allocation strategies. As a simple example, did you know? Small animals like mice have a very fast heartbeat of 600 beats per minute, and their lifespan is only 2 or 3 years. In contrast, elephants have a much slower heartbeat, but their lifespan is as long as 60 or 70 years. There is a theory called the life expectancy per heartbeat hypothesis, that the total number of heartbeats per animal is relatively fixed. Although this theory is not entirely accurate, it does suggest that the lifespan of living things is closely related to their metabolic rate. In the case of humans, our heart rate and body size are just about in equilibrium, neither running out of life too quickly like rats, nor living for hundreds of years with little ability to interact like trees. From an evolutionary perspective, human longevity is also tied to the reproduction cycle. Unlike many animals, we don't survive on our own not long after we are born, but require a long process of growth. If you think about it, it takes almost a decade for a baby to go from birth to being able to hunt on its own. And how can parents support their children's growth if their lifespan is as short as, say, only 20 years? According to scientists, the reason why the human lifespan is just right is that it must cover 2 stages. 1. The parenting stage. Parents need enough time to raise their offspring and pass on their survival skills and social experiences. 2. The grandparenting stage. Grandparents are also important to help take care of their grandchildren and even pass on deeper wisdom. This phenomenon is called the grandmother hypothesis, and studies have shown that families with grandmothers in the home have significantly higher child survival rates. The basis for this is that humans live long enough to complete the cycle of multigenerational collaboration. From a social development perspective, the length of human lifespan is also closely related to the accumulation of experience. Compared to short-lived animals that live for the moment, human society needs a kind of long-term investment. For example, can you imagine a society composed entirely of teenagers? Without the guidance of their elders, it might be difficult to develop complex cultures and technologies. Scientists have found that longevity is particularly important for the transmission of knowledge. In agricultural societies, it takes time to learn and accumulate knowledge about how to grow crops, how to predict the weather, and even how to avoid danger. If lifespans are too short, and key skills are already out of history before they are learned, the society is likely to be difficult to maintain. Even today, the length of life expectancy still has a direct impact on our ability to innovate. For example, many scientists and artists have completed their most important works in middle age or even old age. Darwin was 50 years old when he wrote The Origin of Species, and Leonardo da Vinci was almost 60 when he painted the Mona Lisa. Suffice it to say that the length of the human lifespan gives us plenty of time to think, create, and share. However, life expectancy cannot be unlimited. Imagine the burden on the planet's resources if everyone lived 500 years. Everything from food to housing to social structures would collapse due to overpopulation. And in reality, the natural limits of longevity and the carrying capacity of the environment are a delicate balance. For example, scientists have discovered that DNA ends in a structure called a telomere, which shortens as cells divide. When telomeres run out, cells can no longer divide, and life comes to an end. You could say that this mechanism protects cells from dividing indefinitely, as cancer cells do, and limits excessive lifespan extension. If you look back in history, you'll see that the average lifespan of humans has actually gone through huge changes. In ancient times, lifespans may have been as short as 20 or 30 years, and that was because external factors such as disease, war, and starvation dramatically shortened the length of life. But even then, some individuals could still live into their 50s or 60s, and they were usually the leaders or wise men of the tribe, taking on the responsibility of mentoring the younger generation. As we entered agricultural societies, lifespans began to gradually increase, as food supplies became relatively stable. But it wasn't until after the Industrial Revolution that medical advances really allowed average life expectancy to increase dramatically. For example, the invention of antibiotics saved countless lives, and the spread of vaccines stopped infectious diseases from raging. Today, the average life expectancy in many developed countries is over 80 years. Scientists are still exploring whether life expectancy can be extended even further, such as through gene editing or techniques to reverse aging. Although this may sound sci-fi, it makes us think, how long should we live before it is considered just right? Speaking of which, a story about long and short lifespans comes to mind. You know the green turtle, right? They can live to be over 150 years old, but they also live at a very slow pace and can take decades to mature from birth. Flies, on the other hand, live only a few weeks, but they reproduce, feed, and die in a short period of time. The human lifespan is like a compromise between the two. We are neither so long as to be boring like the tortoise, nor so short as to have no time to leave a mark like the fly. We can live our lives with close family relationships and contribute to the development of society. As technology advances, the human lifespan may be extended even further. Scientists are working on ways to repair telomeres, reduce cell damage, and optimize metabolism. What will society look like if one day we can really live to 150 years old easily, or even longer? Perhaps we will need to redefine life stages. For example, 25 is considered adulthood, 50 is young adulthood, and 100 is old age. However, no matter how life expectancy changes, it is always important to maintain the balance between humans and nature. 4. Light reflectivity of the Earth's surface. Why is it just right to avoid being too cold or too hot? Have you ever wondered why the Earth is neither as cold as Mars as desolate, nor as hot as Venus as barbecue mode? Actually, it has a lot to do with the light reflectivity of the Earth's surface, also known as albedo. What is this albedo? Simply put, it is the ability of the Earth's surface to reflect sunlight. This ability directly determines how much of the sun's energy the Earth can absorb, which in turn affects our climate. Earth's albedo is the amount of light from the sun that is reflected by the entire planet. 0% means total absorption and 100% means total reflection. The actual albedo of the Earth is about 30%, which means that about 1/3 of the sun's light is reflected directly back into space when it hits the Earth. This 30% doesn't just happen, it's closely related to the composition of the Earth's surface. For example, ice and snow have a very high albedo, reflecting about 80 to 90% of sunlight. Therefore, the Antarctic and the North Pole are the most effective natural mirrors on Earth. Oceans have a relatively low albedo, reflecting only about 6% of the light and absorbing the rest. This is why the sea is always so bright in the sun, it absorbs too much light and heat. Forests have a relatively low albedo, about 10 to 20%, while deserts have a relatively high albedo, which can reach 30 to 40%. Okay, now back to the core question. Why is the Earth's albedo a just right 30%? If the Earth's albedo were lower, say 20%, then more sunlight would be absorbed and the Earth would get hotter. On the other hand, if the albedo is higher, say 40%, then the Earth will reflect more sunlight, causing the temperature to drop. It can be said that this 30% albedo provides a golden zone for the Earth's climate. Compare to other planets. Venus has an albedo of 75%. Its atmosphere is thick with clouds that reflect most of the sunlight, but its surface is still super hot, with temperatures as high as 470 degrees Celsius. This is because its atmosphere is filled with carbon dioxide, creating an extreme greenhouse effect. Mars has an albedo of 25%, which is a little lower than Earth's, but because its atmosphere is so thin that it can't effectively insulate itself, it's still very cold, with surface temperatures often below -60 degrees Celsius. As you can see, Earth's albedo is just right not only because it is 30%, but also closely related to the composition of the atmosphere and energy balance. You may ask, is the albedo of the Earth fixed? No, it is not. It varies according to the surface of the Earth, especially the extent of snow and ice cover. A classic example is the ice feedback effect. The effect works like this. When the climate gets colder, the area covered by snow and ice increases, the albedo rises, more sunlight is reflected, and the Earth cools further. In turn, when the climate warms, snow and ice melt, albedo decreases, more sunlight is absorbed, and the Earth warms further. This positive feedback mechanism can amplify climate change. For example, there have been several snowball Earth events in Earth's history. At that time, almost the entire planet was covered with snow and ice, and the albedo rose dramatically, leading to a global state of extreme cold. The surface albedo alone is not enough. The atmosphere also plays an important role. Gases in the Earth's atmosphere, such as carbon dioxide and water vapor, absorb some of the sun's radiation and at the same time lock the infrared radiation that is reflected back from the Earth's surface back into the Earth. This is the familiar greenhouse effect. Without the greenhouse effect, the average temperature of the Earth would be about -18 degrees Celsius instead of the current 15 degrees Celsius. In other words, the atmosphere keeps the Earth neither too cold nor too hot, maintaining a livable environment. Although the Earth's albedo itself is stable, human activity is having an impact on it. For example, deforestation. When forests are cut down to make way for farmland or grassland, albedo rises because plants absorb more sunlight than bare land. Urbanization. Albedo is often low on urban surfaces, especially on asphalt pavement and building materials, which absorb a lot of heat and contribute to the urban heat island effect. Increased greenhouse gases. More greenhouse gases enhance the greenhouse effect, and even if albedo doesn't change significantly, the Earth still gets hotter. Speaking of albedo, an interesting example comes to mind. In the early 20th century, a Swedish scientist, Arrhenius, first proposed a relationship between carbon dioxide and the Earth's temperature. His calculations, though crude, had predicted that if human burning of fossil fuels increased the amount of carbon dioxide in the atmosphere, the Earth would warm. At that time, it was thought to be nothing short of science fiction, but now it has become a cornerstone of climate science. In the future, the Earth's albedo may change significantly due to global warming. Arctic sea ice is rapidly declining, and melting sea ice means that more sunlight is absorbed by the oceans, further exacerbating warming. This vicious circle is the key to scientists' concerns. However, some have proposed the idea of man-made albedo changes, such as spraying reflective particles in the atmosphere to increase the overall albedo of the planet. This approach is known as geoengineering, and while it sounds bold, its side effects and risks are still unknown. 5. Polar ice caps. Why are they just right for regulating ocean flow? Have you ever thought that polar ice caps are actually regulators of the Earth's ocean system? They are like invisible hands that regulate ocean salinity, temperature, and even the flow of global ocean currents by melting and freezing. Without them, our climate could be a mess. So today let's talk about why the polar ice caps are so critical to regulating ocean flow. Let's start with a basic principle. On Earth, ocean water is not static. It circulates around the globe like a giant conveyor belt. One of the driving forces of this conveyor belt is the polar ice caps. When the polar ice caps melt, they release large amounts of fresh water into the surrounding oceans. Fresh water is lighter than salt water, and it floats on the surface of the water, affecting its density. And when the ice cap refreezes, it extracts salt from the surrounding ocean water, making the remaining water saltier and denser. These changes trigger ocean currents, especially deep ocean currents. The prime example is the Atlantic Meridional Overturning Circulation, AMOC, which is responsible for transporting heat from the equatorial regions to the Arctic. Without the involvement of the polar ice caps, the rhythm of this ocean current would be completely disrupted. There are two main aspects to the regulating role of the polar ice caps. The ice caps act as the Earth's natural air conditioners. When sunlight hits the poles, most of the energy is reflected back into space by the icy surface. However, as the ice caps melt, the exposed ocean water absorbs more heat, causing localized temperature increases. This dynamic balance of reflection and absorption directly affects the distribution of ocean temperatures. Warm water is cooled and sinks as it flows toward the poles, a process that drives the circulation of global ocean currents. When the ice caps freeze, they squeeze the salt out of the water, leaving behind water that becomes saltier and heavier. This dense water sinks into the deep ocean, forming a body of water called deep water. This deep water acts as the engine of ocean currents, driving the global circulation of the oceans. In turn, when the ice caps melt, fresh water enters the oceans and lowers the local salinity. This can weaken ocean currents and even cause stagnation in some cases. The history of the Earth tells us that the impact of polar ice caps on ocean currents and climate is enormous. During the most recent ice age, about 20,000 years ago, the polar ice caps were much larger than they are today. At that time, the global ocean circulation system was completely different from what it is now. For example, during that period, more seawater was locked up in the ice caps, causing sea levels to drop by 120 meters. This exposed the continental shelf, linking the land bridges of Asia and North America, an important route that allowed early humans to migrate. And at the end of the ice age, the melting of the ice caps released huge amounts of fresh water, which had a huge impact on the salinity and temperature of the oceans. This process led to a redistribution of ocean currents and may have been one of the causes of the Younger Dryas, a period of rapid cooling of the planet. Today, with global warming, the polar ice caps are melting rapidly. This change is having a profound effect on global ocean flows and climate. The Arctic ice cap is primarily sea ice that floats on the surface of the ocean. Although its melting will not directly raise sea levels, its reduction will allow more sunlight to be absorbed by the sea, accelerating warming. In addition, the melting of Arctic ice is affecting Greenland's ice cap, and its meltwater will change the salinity of the North Atlantic, which in turn will weaken the Atlantic meridional overturning circulation. Scientists fear that if this trend continues, the AMOC could stop altogether. This would not only lead to extreme weather in Europe and North America, but could also trigger a massive collapse of the global climate system. The situation in Antarctica is a little different again. Its ice cap is land ice, which when melted would directly raise sea levels. Studies have shown that if the West Antarctic ice cap melts completely, global sea levels could rise by more than 3 meters. More worryingly, the melting of the Antarctic ice cap would also change the circulation of ocean currents in the Southern Ocean. The Southern Ocean is the starting point of the global ocean conveyor belt, and once the circulation here is disrupted, ocean currents across the planet could be affected. Speaking of polar ice sheet research, here's an interesting story. In 2019, scientists discovered a huge canyon under Greenland's ice sheet, more than 750 kilometers long, longer than the Grand Canyon of Colorado. Hidden under the ice for millions of years, the canyon's existence reveals the complex history of the polar ice caps on geologic time scales. Scientists believe that the canyon may have once been an ancient river channel that formed long before the ice sheet covered it. The team used a technique called ice-penetrating radar. This type of radar can penetrate thick layers of ice and create a detailed map of the terrain below. When they analyzed the data, the deep canyon appeared like a hidden crevasse. Not only did this give a whole new insight into the history of the polar ice caps, but it also provided valuable clues for studying the ecosystems underneath. More interestingly, the discovery got scientists thinking about whether similar hidden terrain also exists in Antarctica. After all, changes in the landforms under the polar ice caps could have important implications for global ocean currents and climate. Another anecdote is that in Antarctica, some lakes have been covered by thick ice for millions of years, such as Lake Vostok. This lake was covered by a 4-kilometer thick ice sheet until the 1990s, when scientists discovered its existence. The water in the lake has been virtually isolated from the outside world for 15 million years, creating a separate microecosystem. Scientists suspect that these lakes may harbor some of the oldest forms of life on Earth, such as microorganisms that are capable of surviving in extreme environments. Interestingly, the study of oriental lakes is not just about exploring the history of the planet. These unique ecosystems have also been used to mimic the environments of other planets, notably Jupiter's moon Europa and Saturn's moon Titan. The surfaces of these planets are also covered in thick ice, under which similar bodies of liquid water may be hidden. Studying Lake Orientia may provide key clues in our search for extraterrestrial life. In the future, the fate of the polar ice caps is closely linked to human actions. If global warming is not curbed, the melting of the ice caps will continue to accelerate. Scientists are trying various methods, such as protecting the polar ice caps by slowing down greenhouse gas emissions. At the same time, there are proposals to use geoengineering techniques, such as creating artificial ice in the polar regions, to slow down the rate of melting. These ideas sound sci-fi, but with advances in technology, they may one day become a reality. The polar ice caps are an integral part of the Earth's ocean system. By regulating the salinity and temperature of the oceans, it drives the circulation of global ocean currents and maintains a stable climate. It is this just right balance that makes our planet so livable. However, this balance is fragile. Protecting the polar ice caps is not only for the sake of the distant snow and ice, but also for the sake of all life on Earth, including our own. 6. The rate of movement of the Earth's crust. Why is it just right to support the diversity of life? Has it ever occurred to you that the Earth beneath our feet is never at rest? Although we stand on the ground and think that everything is stable, the Earth's crust is actually jogging all the time. The rate of movement of the Earth's plates is not fast or slow, just right. And this just right directly determines the diversity of life on Earth. How fast is plate movement? Let's start with a visualization. The Earth's crust moves at a rate of a few centimeters per year, which is about how fast your fingernails grow in a year. Sounds slow, right? Don't underestimate the speed, but over the years, plate movement can cause continents to drift by thousands of kilometers. About 200 million years ago, all the continents used to be connected into one giant supercontinent Pangaea. As the plates slowly broke apart and drifted, the 7 continents we know today gradually took shape. What would happen if the plates moved too fast? Earth could become a world of catastrophes. Rapid plate movement would lead to frequent large-scale volcanic eruptions and earthquakes. Volcanic eruptions not only destroy local ecosystems, they also release large amounts of gases into the atmosphere, such as carbon dioxide and sulfur dioxide, which could lead to dramatic changes in the global climate. For example, the Permian-Triassic extinction event, also known as the Great Extinction, which occurred about 250 million years ago, may have been associated with large-scale volcanic activity triggered by plate movement. At that time, huge magma eruptions occurred in the Siberian Shield, which released large amounts of greenhouse gases into the atmosphere and caused the Earth to become extremely hot, resulting in the extinction of 80% of marine species and 70% of terrestrial species. Such large-scale ecological catastrophes could be more frequent if the plates were moving too fast. So what happens if the crust moves at a snail's pace? This in turn would leave the Earth dead. Plate movement is one way the Earth renews its ecosystem. When plates collide, high mountains are formed, such as the Himalayas. When plates separate, new ocean basins are created, such as the Atlantic Ocean. These geologic events provide diverse habitats for life. If the plates were barely moving, the emergence of new ecosystems would be extremely limited. Ocean and land environments would tend to homogenize, and the diversity of life would be greatly reduced. Imagine what an Earth without crustal movement would look like. It would probably be a flat wasteland, lacking in diverse ecosystems, and magnificent landscapes like the Himalayas would not exist. In addition, crustal movements have a direct impact on the climate and biological evolution of the planet. For example, when the plates of South and North America collided to form the Isthmus of Panama, it connected the 2 continents and at the same time cut off the ocean passage between the Atlantic and Pacific Oceans. This event, known geologically as the Panama Event, changed the global ocean current system and even influenced the evolution of the Earth's climate. Similarly, when the Indian Plate collided with the Eurasian Plate to form the Himalayas, the roof of the world, this geological event not only shaped the magnificent natural landscape, but also changed the climate system in Asia, making the Indian monsoon stronger. These climatic changes have directly impacted ecosystems, thus driving the evolution and adaptation of species. Speaking of plate movements, there is one particularly interesting place that has to be mentioned: Iceland. Located on the mid-Atlantic ridge, Iceland is one of the few places on Earth where plate boundaries are visible. Here, the North American and Eurasian plates are slowly separating, moving about 2 centimeters per year. What's even more interesting is that visitors can dive into Iceland's Thingvellir Rift and touch the edge of the two plates. It's like putting your hands on two continents that are drifting apart, isn't it incredible? Iceland's geology is also rich in geothermal resources. The large amount of volcanic activity has turned the country into a hot spring paradise, and even most of the population's electricity comes from geothermal energy. Plate movements not only shape the Earth's landscape, but also provide opportunities for biological evolution and diversity. For example, continental drift separate species in different regions, prompting them to evolve new characteristics in isolated environments. This is why Africa, Australia, and South America are home to so many unique creatures, such as koalas, giant kangaroos, and jaguars. Scientists have also found that alpine zones formed by plate collisions, such as the Andes, have one of the highest levels of biodiversity on Earth. Plants and animals here have had to adapt to the specialized conditions of high altitude, such as oxygen scarcity and extreme temperature differences, and have thus evolved a rich variety of survival strategies. If we fast forward a few 100 million years, what does the future of crustal movements look like? Scientists predict that existing continents could reconverge to form new supercontinents. This hypothesis is known as Pangaea Ultima, meaning the ultimate Pangaea. At that point, the ocean basins could disappear, and new geological features would once again change the Earth's ecology. Of course, such a change would take hundreds of millions of years, so we can probably only imagine it. But what is certain is that crustal movements will not stop, and the Earth's geomorphology and ecology will continue to evolve. In short, the rate of crustal movement is not random, but has taken a long time to evolve and adjust to the current just right. This rate is sufficient to create a variety of ecosystems without plunging the planet into frequent catastrophes. It is not only the architect of the diversity of life on Earth, but also an important guarantee of the long-term climate stability of the planet. 7. Ocean temperature gradient. Why is it just right to support deep-sea ecology? Has it ever occurred to you that the oceans are actually layered? And these layers don't appear randomly, but are determined by temperature. The temperature gradient from the warm surface layer, to the cooler mesopelagic layer, to the almost ice-cold deeper layer, provides a customized habitat for marine life. Each layer has unique temperature, pressure, and light conditions that are adapted to the organisms at different depths. Without this gradient, the marine ecosystem would be completely different. How is the temperature gradient formed? To understand the ocean temperature gradient, we have to start with sunlight. Sunlight is the main source of warmth in the oceans, but it can only penetrate a few tens to hundreds of meters into the surface layer. As a result, the oceans form a hot and cold layered structure from the surface to the depths. Scientists roughly divide it into 3 layers. 1. Surface ocean. This is where the sunlight reaches and the temperature is high, usually between 10 degrees Celsius and 30 degrees Celsius. The water is often exposed to wind and waves. The water here is often stirred up by wind and waves, so the temperature does not vary much, making it ideal for fish and plankton in the surface layer. Zweiter Liebfrugtemperaturzone, mesopelagic. This is a transitional zone where the temperature drops rapidly with depth, usually from 20 degrees Celsius to about 4 degrees Celsius. The temperature of the thermocline is usually around 4 degrees Celsius, but the temperature of the mesopelagic zone is about 4 degrees Celsius. The thickness and depth of the thermocline varies from region to region, but it is the heart of the ocean temperature gradient. 3. Deep ocean. This part of the ocean is virtually unaffected by sunlight and has a constant temperature of around 4 degrees Celsius. This is where the cold and stress-tolerant animals live. It is a haven for hardy stress-resistant deep-sea creatures such as giant squid, deep-sea fish, and stunning deep-sea corals. Each layer of the ocean provides a unique environment for organisms to live in, and these environments are closely linked to temperature changes. The surface layer is the area of greatest biodiversity. Why? Because it's sunny enough for phytoplankton to photosynthesize and become the basis of the entire marine food chain. In case you didn't know, more than 70% of the primary productivity, i.e., the making of food in the ocean, comes from these tiny phytoplankton. The warmth of the surface layer also attracts many sunbathing marine animals, such as dolphins, sea turtles, and tropical fish. They like to feed, breed, and even play here. Scientists have filmed a group of dolphins jumping around a coral reef with a drone, which makes you think that the ocean is really a beautiful playground. The thermocline is one of the most mysterious parts of the ocean and a refuge for many marine creatures. Here the temperature drops dramatically, allowing the water to separate into different layers. Sharks, for example, like to use the thermocline to hide, resting in the cold water and quickly rushing up to the warmer surface to feed. Even more amazingly, the thermocline also affects the propagation of sound waves. Submarines often take advantage of the temperature difference to form acoustic channels, to avoid detection by sonar. Similarly, marine mammals, such as sperm whales, use these properties of sound waves to communicate and even hunt. The cold temperatures and high pressures of the deep sea may be hell for us humans, but for some creatures it is paradise. Giant squid, tube worms, deep-sea fish, and other seemingly alien creatures thrive in the darkness. The deep sea also hides hydrothermal vents, where temperatures of up to 400 degrees Celsius can be a hotbed of life, inhabited by countless heat-tolerant microorganisms. The metabolic rate of deep-sea organisms is very low, which is closely related to the cold environment of the deep sea. Scientists have found that some deep-sea fish may live for up to 100 years because of their very slow rate of cellular damage at low temperatures. The temperature gradient in the ocean not only provides habitat for organisms, but also directly affects nutrient cycling and global climate. Temperature gradients drive upwelling in the oceans. Deep, cold water rises to the surface, bringing with it large amounts of nutrients. These nutrients are utilized by phytoplankton, creating highly productive ocean oases. The upwelling off the coast of Peru, for example, supports countless fish species and is one of the world's most important fisheries. Temperature and salinity work together to create global ocean current systems, such as the Atlantic Meridional Overturning Circulation, AMOC. These currents regulate the Earth's climate, for example by transporting heat from the equatorial regions to the poles. If the temperature gradient were to be disrupted, this circulation could come to a halt, leading to drastic changes in the global climate. Speaking of ocean temperature gradients, it is important to mention a surprising discovery. Near hydrothermal vents in the Pacific Ocean, scientists have found a special community of organisms. These organisms are completely dependent on chemical energy, rather than sunlight, for their survival, such as spiral-shaped bacteria that synthesize organic matter from sulfide. More interestingly, these organisms may provide clues to the search for extraterrestrial life, as Europa's under-ice ocean may have a similar ecosystem. Another story comes from the research vessel Challenger, a 19th-century expedition that first revealed the layered structure of the oceans and gave mankind its first real understanding of the complexity of the deep sea. Using simple thermometers and sampling buckets, scientists pieced together this delicate gradient picture step by step. Although the system may seem stable, it is in fact very fragile. Global warming is changing the temperature of surface waters, and freshwater inputs from melting glaciers could disrupt the formation of the thermocline. Scientists have already observed weaker upwelling in some areas, directly affecting fishery resources. If the temperature gradient is further disrupted, deep-sea organisms could lose their habitat, and the global climate system could be severely impacted. For example, a weakening of the AMOC could lead to colder winters in Europe or even trigger a little ice age-like phenomenon. In short, the ocean temperature gradient is a delicate design of nature, which not only provides a suitable environment for organisms at different depths, but also maintains the ecological balance of the whole planet. From the surface in the sunlight to the deep sea in the darkness, each layer plays an irreplaceable role in its own stage. 8. Biological clock cycle. Why is it synchronized with the Earth's rotation? Have you ever thought that our daily routine of sleeping, waking up, eating and working is actually organized by some invisible force? And this set of arrangements is not set by ourselves, but written in the body's program, deeply embedded in our genes. The secret behind this is the familiar and unfamiliar biological clock, a wonderful rhythm that is perfectly synchronized with the Earth's rotation cycle. Let's talk about why the rhythm of a living organism is about 24 hours. The Earth rotates once a day, alternating day and night, and this process is fixed. Life has been growing in this environment since its inception. Both the earliest microorganisms and today's advanced mammals have been forced to adapt to this rhythm. It can be said that the biological clock is a kind of mapping of the Earth's rotation within life. Scientists have found that the biological clocks of most animals are not exactly 24 hours, but are slightly longer or shorter. For example, the internal rhythm of humans is about 24.2 hours. This conclusion was reached through isolation experiments. In the experiment, people were put into an environment with no time cues at all, such as an underground laboratory with no windows, no daylight, and no clocks. As a result, sleep and wake times drifted towards a 24.2-hour cycle, but once exposed to sunlight, the rhythm was immediately calibrated back to 24 hours. The biological clock is not a simple alarm clock, but a complex system. It controls not only when we should go to sleep and when we should get up, but also almost all physiological activities, body temperature, hormone secretion, cellular repair, and even the activity level of the immune system. For example, your body temperature will be at its lowest point in the morning when you first wake up, and at its highest point at 2 or 3 p.m. That's why some people find the late afternoon to be the peak time, especially for work or exercise. On the other hand, a drop in body temperature at night makes us feel sleepy, which is a reminder from the biological clock that it's time to rest. Another example is the production of melatonin, which is controlled by the biological clock. Melatonin, a hormone that helps us fall asleep, usually begins to be secreted after dark and stops in the morning at dawn. This mechanism is closely related to the alternation of day and night on Earth. If you stay up late or are exposed to bright light, melatonin production is suppressed and you may find it difficult to fall asleep. Why is the biological clock in tune with the Earth's rotation? Synchronizing the biological clock with the Earth's rotation seems natural, but it's actually quite incredible. Imagine what would happen if our biological clocks were not synchronized with the Earth's rotation. If our biological clocks are 20 hours long, that means we would run too fast throughout the day. For example, you may wake up at 8 a.m., but at 4 a.m. the next morning you are fully awake, and then at 12 a.m. the third day you wake up again. So on and so forth. Work and rest will be completely out of sync with the day and night. In the long run, physiological dysfunction, decreased immunity, and even lead to illness. Similarly, if the biological clock is 30 hours, our body rhythm will run too slow. Every day we feel that we do not sleep enough, daytime drowsiness, but the night is full of energy, which will make us become extremely tired, but also not conducive to survival. It is because the cycle of the biological clock and the rotation of the Earth are highly compatible that living organisms are able to function properly in an environment of alternating day and night. And this fit, apparently, was achieved through a long period of natural selection. You may ask, the Earth's rotation cycle is fixed, so how did the biological clock evolve? The answer lies in the survival of the fittest. Organisms that could not adapt to the circadian rhythms would have a hard time surviving the competition. Early photosynthetic bacteria, for example, had to absorb sunlight during the day to carry out photosynthesis. If they could not work during the day, they could not produce enough energy and could be eliminated. Similarly, the biological clocks of nocturnal animals are tuned to be more active at night so that they can avoid predators or utilize nighttime resources. Interestingly, the mechanism of the biological clock has striking similarities across organisms. For example, the genes at the heart of the biological clock in fruit flies and humans are very similar. By studying fruit flies, scientists have discovered the clock gene that regulates the biological clock. This gene is responsible for producing a protein, the concentration of which changes over time, forming a pendulum-like periodic fluctuation. When the biological clock gets out of sync with the Earth's rhythms, our bodies protest. The most common example is the jet lag reaction. After traveling across multiple time zones, our biological clocks need to readjust to local time. This process can take several days, during which time we may feel tired, have difficulty concentrating, or even suffer from indigestion. There is also a modern disease called social jet lag. Many people stay up late on weekends and then have to get up early on Mondays to go to work, resulting in their biological clocks being repeatedly disrupted. The health effects of this lifestyle are no less than those of real jet lag, such as obesity, diabetes, and even cardiovascular disease. There are some particularly interesting studies and stories about the biological clock. In the 18th century, the Swedish botanist Linnaeus designed a flower clock with different flowers arranged in the shape of a clock according to the flowering time. Because plants have their own rhythms, certain flowers open and close at fixed times, such as the dandelion, which wakes up at 5 a.m., or the nightshade, which goes to bed at 7 o'clock in the evening. You might think that a biological clock would be useless in the deep sea, where it is completely dark. But scientists have found that many deep-sea creatures still have circadian rhythms. For example, certain fish migrate through the depths as the sun rises and sets. They may not perceive light, but subtle changes in water temperature and pressure are enough to trigger the biological clock. French explorer Michel Siffre, in an effort to study the human biological clock, locked himself in an underground cave several times, completely cutting off time from the outside world. He found that, despite the absence of daylight, His biological clock maintained a near 24-hour cycle, but also drifted gradually, further proving the importance of sunlight in calibrating the biological clock. Today, scientists are investigating how the biological clock can be used to improve our health. For example, an emerging field called chronomedicine focuses on optimizing the timing of treatments based on the biological clock. Studies have shown that certain medications work better when taken at certain times. For example, antihypertensive medications may be more effective when taken at night, when blood pressure is usually lower. Others have developed biological clock-friendly lighting systems. For example, smart lighting devices can mimic the changing light of sunrise and sunset to help adjust our biological clocks. This is particularly useful for those who work long hours on night shifts. In short, the synchronization of the biological clock with the Earth's rotation cycle is definitely a just right arrangement in the universe. It keeps us in tune with our natural rhythms and supports the normal functioning of our living organisms. Whether we are working, resting, eating, or reproducing, this inner rhythm is silently guiding us. 9. Intervals between Earth's magnetic field flips. Why just enough to avoid too many extinctions? When it comes to the flipping of the Earth's magnetic field, you may find it a bit incomprehensible. In fact, such flips have indeed occurred hundreds of times throughout Earth's history. However, it is a relief to know that the Earth's magnetic field flips at very just the right intervals, neither so often that organisms become extinct, nor so infrequently that they lose their protective effect. So why is the magnetic field flipping just right? Let's start with a brief explanation of what a magnetic field reversal is. The existence of the Earth's magnetic field is like an invisible protective shield, generated by the movement of liquid iron in the Earth's core. The main role is to resist high-energy charged particles from the sun, also known as the solar wind. The shield has a key feature: its north and south poles are not always fixed, but sometimes flip, that is, the magnetic north pole and magnetic south pole switch positions. This flip is not an instantaneous snap like a switch, but a slow process that can take thousands to tens of thousands of years. During this time, the Earth's magnetic field can become very chaotic, and sometimes there are even multiple magnetic poles, forming a complex multipole distribution. If you look at the geologic record, the Earth's magnetic field flips unevenly. The most recent major reversal was called the Brong-Matsuyama event, which occurred about 780,000 years ago. Further back in time, we can find some periods of particularly frequent fluctuations, such as the Mesozoic era, 200 million years ago. Every few 100,000 years there will be a flip. But there were also magnetically quiet periods, such as the Cretaceous, from about 120 million years ago to 83 million years ago, when there were no flips at all for 40 million years. Scientists have used the rock record to study these flips and have found that the Earth's magnetic field flips at irregular intervals, but on average, they occur about once every 200,000 to 500,000 years. Why is the just right interval important for life? If the Earth's magnetic field flips too often, it could be a big problem for living things. During an overturn, the Earth's magnetic field is significantly weakened or even partially disappears. In this case, energetic particles from the Sun and the universe would reach the surface more easily, increasing radiation exposure. Humans are fine because we are protected by technology and buildings, but for organisms that depend on the surface environment, such as birds, insects, and even microorganisms, the increased radiation could be genetically damaging. As an example, studies have shown that solar storms can interfere with the navigation systems of birds and marine animals, which rely on the Earth's magnetic field for orientation. Imagine if the magnetic field flipped very frequently, these species could become disoriented and die in large numbers. Although magnetic field flipping is primarily an internal Earth phenomenon, its indirect effects on climate cannot be ignored. Some scientists speculate that a weakening magnetic field could lead to more cosmic rays entering the atmosphere, which could affect cloud formation. This could cause the climate to become more extreme, such as more frequent blizzards or droughts. If the flip-flops are too frequent, organisms may not have enough time to adapt to the new environment. Biological evolution on Earth is a long and complex process. If the intervals between magnetic field flips are too short, organisms may be disrupted by the next round of flips before they have time to adapt to the new environmental changes. For example, during magnetic field flips, the atmospheric ozone layer may be damaged by more energetic particles, and a weak ozone layer increases ultraviolet radiation, which can be fatal to surface organisms, especially plants and plankton. However, the available geologic record shows that Earth's biomes have generally survived magnetic field flips, despite the stress they may cause. This may suggest that the time between flips was just right, allowing species enough time to adapt or evolve. While magnetic field flips do not directly cause mass extinctions, they may have a profound effect on ecosystems at some point. One interesting speculation is that magnetic field flips may have had something to do with the extinction of the Neanderthals. About 42,000 years ago, the Earth experienced a brief magnetic field flipping event called the La Chaux-de-Fonds event. During this process, the strength of the magnetic field weakened dramatically and the Earth's protective capacity was reduced. Some research suggests that this may have led to a sudden change in climate that put a deadly strain on the Neanderthals. However, there is no conclusive evidence for this theory. In addition, birds and marine animals often rely on the geomagnetic field for navigation. If the magnetic field suddenly becomes chaotic, they could become disoriented. For example, some sea turtles have been documented to swim in the wrong direction in areas with abnormal magnetic fields and end up stranded in places that are not suitable for survival. To study the effects of magnetic field flipping on life, scientists have designed many interesting experiments. They have reconstructed the history of magnetic fields over hundreds of millions of years by studying magnetic minerals in volcanic and sedimentary rocks. Volcanic rock remembers the direction of the Earth's magnetic field as it cools, like a historical diary. Surprisingly, some records show that the magnetic field flip was not an instant on-off switch, but a gradual evolutionary process. In the laboratory, scientists used powerful magnetic field devices to simulate magnetic field flips and observe the effects on living organisms such as bacteria and plants. They have found that some organisms are very sensitive to changes in magnetic fields, but also have the ability to adapt. Our current Earth's magnetic field is weakening. Scientists have monitored that the strength of the geomagnetic field has dropped by about 10% over the past 150 years. Does this mean a new flip is imminent? No one knows for sure, but if it does, the planet's technological civilization could face a big test. The good news is that mankind has mastered enough technology to create artificial barriers to protect critical equipment. In short, the intervals between flips in the Earth's magnetic field are another of nature's just right arrangements. It occurs sparsely enough to give organisms time to adapt, but it is not completely static, giving life a chance to evolve and adjust. The historical record shows that magnetic field flips, while challenging ecosystems, have also contributed to the resilience and diversity of life on Earth. 10. The amount of metal in stars. Why is it just enough to support planet formation? Understanding how a star's metal content affects planet formation is, I would say, one of the most just right miracles in the universe. If a star's metal content is too low, an entire planetary system may not exist at all. If it's too high, it may lead to an unstable star or a planet with characteristics that are unsuitable for life to flourish. The fact that we are sitting here on Earth today talking about this topic is due to the fact that the metal content of stars is just right. Let's start with a little background. In astronomy, all elements except hydrogen and helium are called metals. This may sound strange, but that's how scientists define it. When the Big Bang first happened, there was only hydrogen and helium, and then the metallic elements were created by stars through nuclear fusion and supernova explosions. So when we talk about the amount of metals in a star, we're really talking about the amount of those heavy elements. To give you an example, the amount of metal in our Sun is about 2%. That may seem like a small amount, but it's enough to form rocky planets like Earth, and gas giants like Jupiter. If the Sun had a much lower amount of metals than this, such as almost no metals like the first generation of stars, the solar system probably wouldn't exist. Why does the amount of metal matter? The amount of metal in a star directly affects the formation of planets. Where do planets around stars come from? Simply put, they form from the primordial nebula in which the star was born. This nebula contains not only hydrogen and helium, but also metallic elements such as silicon, iron, and oxygen. These heavy elements formed the cores of the rocky planets through accretion, while the gas giants gravitationally captured a lot of the surrounding gas. If a star's metal content is so low that there is barely enough solid material in the nebula, the process of planet formation can be very difficult. Studies have shown that planetary systems are less likely to be found around low-metal stars. This is why very old stars, such as first-generation stars that are more than 10 billion years old, have few planets orbiting them. On the other hand, the problem comes if the amount of metal is too high. Too much metal can cause too much solid material to appear in the nebula, which can cause planets to form so large or so close together that they become extremely unstable. Some close-by hot Jupiters, for example, are so close to their stars that their surface temperatures are thousands of degrees Celsius, making it almost impossible for them to harbor life. Fortunately, the Sun's metal content is in a very favorable range. It's high enough to form rocky planets like Earth, but not too high to keep planetary systems relatively stable. Scientists often say that our Sun is a second-generation star, one that formed after an earlier star exploded. That explosion mixed hydrogen, helium, and metallic elements into the nebula that eventually became today's Sun and solar system. Interestingly, every planet in our solar system seems to have gotten a piece of the pie from this distribution of metals. Rocky planets like Earth contain large amounts of silicon and iron, while gaseous planets like Jupiter are made up mostly of hydrogen and helium, but with some metals in their cores. This diversity makes our solar system a cosmic testing ground full of possibilities, with environments suitable for life and many strange planets to study. So what is the relationship between stellar metallicity and the habitable zone? The amount of metal not only determines whether planets can form, but also affects the location of the habitable zone in a planetary system. The so-called habitable zone is a region around a star that is neither too cold nor too hot, where water can exist in liquid form, which is thought to be necessary for life to form. Scientists have found that stars with high metal content tend to have more rocky planets in the habitable zone. As an example, many of the Earth-like planets discovered by the Kepler Space Telescope are orbiting stars with high metallicity. This suggests that the amount of metal is a key factor in whether a star system is likely to harbor life. Have you heard of Kepler 452b? It's a super-Earth discovered by the Kepler telescope that orbits a star with a slightly higher metal content than the Sun. Scientists believe that it may have an Earth-like environment and may even have liquid water. What's even more interesting is that the star is 1.5 billion years older than the Sun, meaning that if there is life on Kepler 452b, it could be much more advanced in its evolution than we are. It makes one imagine that perhaps there is a civilization similar to ours far below, working on their own cosmic fit. Although we already know the importance of stellar metallicity in planet formation, there are still many unanswered questions. For example, scientists are still studying why some high-metal stars form very chaotic planetary systems, while others are relatively stable. Also, with the James Webb Space Telescope in operation, we will be able to observe the metal content of distant star systems in greater detail. Perhaps one day we will find a second Earth, and verify the critical role of metal content in the development of life. Well, that's it for this installment. Thanks for watching and for the likes and comments.